So for the rest of the lecture, we're going to cover some more general formulas, and the first set of formulas is the addition subtraction formulas. So they're again given here on the slide. They look complicated, but if we look at this for a little bit, you'll see that there's actually some structure to these formulas. You don't have to memorize them verbatim, you can consult them. But what I encourage you is to at least become familiar with it so you can quickly find which formula you need and apply it. You won't have time on the exam to, from first principles, rederive what you need to do. As to the structure, what I would point out here is that there's two sets of formulas. There's one for sine, and there's one for cosine. And the structure for the one for sine, let me duplicate it. Here, what you end up seeing is that it's always, and let me put sine and cosine in two different colors. So it's sine, cosine, and then cosine, sine. And that's the same thing for alpha minus beta. So we have sine, cosine, cosine, oops, wrong color, sine, and then for cosine A plus B, actually let me fill in the rest of the formula first. So then the angles are alpha, beta, alpha, beta, alpha, beta, alpha, beta. And now look at the signs. And I'm going to make it very colored. So the sign for sine is always the same as what you have in the parentheses. So this is, here you get a plus, and here you get a minus. So that gives you sort of a schematic overview of how this formula is built up. And then continuing for cosine. So for cosine, it's always cosine first, so cosine, cosine, and then sine, sine. And it's the same structure for alpha minus beta. So we have cosine, cosine, sine, sine. Now I put the angles, alpha, beta, alpha, beta, alpha, beta, alpha, beta. So all of that stays the same. Now look at the signs. So now the signs are the opposite of what you have. So here we had, here's my yellow, same sign, and here we have opposite sign. So here we have minus, and here we have plus. So that gives you maybe a little bit of a crutch to memorize how the formulas are built up. You can derive the formulas if you want to, but we will not see that in this course. So what you basically have to do is draw a certain triangle in the unit circle. And then rotate it by a certain amount. We will not cover this. What we can do is play with these formulas a little bit. So let's look first of all at maybe a slightly contrived example. Let's compute sine of 7 pi over 12. So this is not a value that we're comfortable with, one from the table. But we can write this as, if you look at the fraction a bit, as pi over 4 plus pi over 3. And then applying the addition subtraction formula, what we get is that this works out to pi over 4 cosine pi over 3 plus cosine pi over 4 sine pi over 3. If you apply this kind of formula, you have to make sure that what you end up with here, this should be known values. Values for which you know sine and cosine. If you have something that you don't know the sine and the cosine for, it's probably not going to get you very far. So now we can work this out because we know these values. This is square root of 2 divided by 2. This right here is 1 over 2. This is again square root of 2 over 2. And this is square root of 3 divided by 2. And if we clean it up and simplify it a little bit, we get square root of 2 plus square root of 6 divided by 4. Let's do another example. Let's have a look at cosine of pi divided by 12. Again, pi over 12 is not an angle that we know by heart what cosine is, but we can write this as cosine of 3 pi over 12 minus 2 pi over 12. Sometimes these decompositions have to think a little bit, because again, you want these things to be known values, and they are known because if you simplify the fractions here, you get cosine of pi over 4 minus pi over 6. We again apply the addition subtraction formula, pi over 4 cosine pi over 6 plus, remember for cosine it's always the opposite sign, sine pi over 4 sine pi over 6. These values we know. This is square root of 2 over 2. This right here is square root of 3 divided by 2. Square root of 2 divided by 2 and 1/2. And then again cleaning up and simplifying, and we get square root of 2 plus square root of 6 divided by 4. It's the same answer as before, but that is at this point a little bit of a coincidence. So then there's one more set of addition subtraction formulas, and those cover the tangent. So they're listed here, and we can try to derive one of them because they follow from what we already know. So if we take the left-hand side, we get tan alpha plus beta is equal to sine alpha plus beta divided by cosine alpha plus beta. Now I'm going to work that out with the addition subtraction formula for sine and cosine. So this is going to be a bit messy. This is sine alpha cosine beta plus cosine alpha sine beta divided by cosine alpha cosine beta minus sine alpha sine beta. So we want to get to something that looks a little bit like the right-hand side here. And well, I've got something plus something else here, and the numerator here has also some, but I'm not there yet. And what I really would like to see is I want to get something that looks a bit like tan alpha here and tan beta here. So I'm putting these between quotation marks. They're not equal, but I want to make them equal, and I need to do some tricks to get there. So how can I make them equal? Well, let me write down what I have in the first term. I have sine alpha cos beta. So what I'm going to do is I can make that into tan alpha if I divide by cosine beta, and I divide by cosine alpha. If I just look at these terms in isolation, that gets rid of the cosine beta here, and that turns the sine alpha into a tangent. And I'm going to take this term here and just copy it verbatim. So now I've divided the numerator by cosine alpha, cosine beta. Now I have to do the same thing to the denominator, otherwise the result is not correct. So let me copy the denominator, sine alpha, sine beta, and now I have to divide this thing also by cosine alpha, cosine beta. So it's looking very messy. Let's make it a little bit more messy still, and let's write it as one gigantic fraction where we split up the top and the bottom fraction. So we write it as sine alpha cosine beta cosine alpha cosine beta plus cosine alpha sine beta cosine alpha cosine beta, and then in the denominator cosine alpha cosine beta cosine alpha cosine beta minus sine alpha sine beta cosine alpha cosine beta. So it's probably the messiest expression that we've constructed so far in this class, but now it's going to really clean up. So if I look at each fraction, I see this cancels against this cancels against this, this cancels against this cancels against this, and I think we're done with cancellations. Now if you look at what remains, sine alpha, cosine alpha, that's tan alpha, that's great, that's what we wanted. Sine beta, cosine beta, that's tan beta, wonderful. Here everything disappears and we're left with 1 minus, and then here we have sine alpha, cosine alpha, that's tan alpha, sine beta, cosine beta, tan beta. And that gives us our formula that's on top here. You can do the other one, the minus one, in exactly the same way, or you can use a shortcut to say, well, alpha minus beta, that's alpha plus beta, alpha plus minus beta, and then reuse the same formula.